Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to start today a new topic which is a part of our last chapter, velocity in mechanism. There is two methods are there, relative velocity and second is the instantaneous center. So right now we are going to start the instantaneous center method for finding velocity of any point or any component of mechanism. Okay, let's start. Okay, before starting this topic, we have to understand types of motion in an element. So first of all, I can say if I am giving some point here, so check this, there is a point or center of crank, and if crank is rotating, maybe rotation can be total, complete revolution or partial rotation can be there. So this type of motion means there is some reference point with respect to it is rotating, so it is a rotation. But when I am saying that translatory motion means this link in this condition and it will move in this direction. Okay, so you can check this, like without changing the position, it is a so if it is moving in this direction, it can be said that it is a translatory motion. But when I am saying that with respect to this point, sorry, I am saying that if this in a link in this position and it is moving and second position is changed to like this here, so what it is, so it can be combination of both, means link is moved from this position to here first, and after that it is rotated in this direction and it is become here. So that is a combination. So this type of combination is there, and it is you can't detect which type of motion is there because it changes gradually. Okay, so in actual practice the motion of links are so gradual they are difficult to separate the both motion. So let's check. So we have to assume that first motion is that like this. If AB link is here, so you can check AB link is here and it is moved first linear or translation here from AB to AB, A dash, B dash, and after that means coming at this position, it is rotated. So first translatory motion and then rotary motion. Maybe possible that we can assume same motion in a second way. We can say that link is first in a AB condition, after that it is moved to A B dash condition, rotary motion first and then translatory motion like this, from it is going from this point to this, and this translatory motion from this position to the here A1 B1. So in both case what we have assumed, there is a both motion are there, in first case translatory then rotary, and in second case first rotary and then translatory. But we can find some point, any reference, maybe any out of this link, with respect to that point this AB link is rotating pure rotation, means making pure rotation with respect to that point. So this point means with respect to this AB link is rotating pure rotation. It is known as a instantaneous center. How we can find that? Check here. First of all, this is a AB link is here. It is moved to second position here, A1 B1, and in this motion is a combination of both rotary and translatory. But now I am going to connect this A1, and from the center of this line A1 perpendicular to that line I will draw the line, perpendicular means bisect, and connect the B1, and from the midpoint I will again perpendicular to that link, and it is intersecting at a point I. Okay, here. So this point is a I center for AB, means with respect to this point AB is a pure rotating. Okay, because whenever you understand the pure rotation, we can find the relation between linear velocity also. If you know the angular velocity, you can find the linear velocity very easily. So if you know that this I point, with respect to this I point, AB is pure rotating, means omega will be there, and from this distance from this I to A or I to this B, you can find the linear velocity also. So that's how we will use this I center method. Okay, check this definition for that. Combination of motion of both rotation and translation of AB link may be assumed to be pure rotation. Okay, pure rotation about some center. Which center? I center, which is known as a I center. Okay, so it is a instantaneous center of rotation, and with respect to that, AB link is a pure rotating. Okay, although there is a combination of rotation and translation. So now we are going to learn how types of this I center, how we can locate that I center. Okay, let's start. Location of instantaneous center. How we can locate? So first of all, when there is only two links are there, A link number 1 and link number 2, which are connected. So connection point, the point of connection is a I center. This is the I center. It is known as the I12 because with respect to this point, link number 1 and link number 2 are rotating here. Okay, in this direction, or maybe consider one in this direction, but both are rotating with respect to this I12, which is a common or joint between them. Okay, after that, second criteria, when there is a slider sliding on a flat surface. So how can you imagine the point with respect to this slider is a pure rotation? Because it is the pure translatory motion in there. Slider is a translatory. But if you consider the I center at an infinitive distance, at infinitive, okay, it will consider as a pure translatory. Okay, because if you consider the, if I am giving you an example, this is the slider. If you say that infinitive radius circle is there and component of that circle will be considered as a straight line. Okay, so after that, if the roller is a rolling on a straight surface, the contact point will be considered as a I center. And if the slider is a sliding in a circular path, if this slider is sliding in a circular path, okay, so center of this curvature part will be considered as the I center, because you check here, if it is sliding here in this direction with respect to this, it is pure rotation. Okay, that's why it will be considered as a I center. And last point is if the same as a slider sliding on above the circular surface, then the I center will be considered as a center of that curvature. Okay, that's it. But out of that, these 2 points, these 2 types are very useful, because in our mechanism there is a points like link are connected. So these type of location we will use these 2 types. Okay, slider and link. Now we are going to find the numbers of I centers. How many centers should be there, and how can find? So first of all, we have to find how many I centers are there. So there is a relation is there, n minus 1 into n by 2. So n is a number of links. Like you can say, you can check here, there is a 2 links are there, link number 1 and link number 2. So for 2 links, you can say there is a 2 here, the 2 minus 1, 1 into 2 divided by 2. So between 2 links there is a I center is only 1. But you can find that if n is a 4 links are there, so you can find the how many I centers should be known. So for 4, number of link 4, you can find 6 eye centers. Okay, so this is the relation which is very useful, because you must know the how many eye centers you should find in any mechanism. Depends on the number of links. Okay, so first of all, now we are going to start the types of eye center. How many types? There are 3 types of eye centers are there. First let's check this example. This is the 4-bar chain mechanism, which already we know that there is a 4 links are there. 1, this is number 3, number 2, and link number 1, which is fixed. So 4 links are there, and how many eye centers? You know that eye centers are 6 here. You can check here this eye center, you already find it. So I124, I13. And how we can find this eye center? This will be covered in a next slide. First of all, right now we are going to check how many types of eye centers are there. So you can see here this link number 1 and link number 4 is connected here. The joint point it is a I14, and link number 1 and link number 2 connecting point is here, so it is known as a I12. So you can check here, this point will be permanently be here. If this link is rotating, this point will not move. It will be in a steady condition, because 2 is pure rotating. 2 is pure rotating with respect to this point, and this point will be here. So that's why it is known as a fixed eye centers. Okay, fixed eye center. And after that, check this point, connection between link number 3 and 4 and connection between 2 and 3. This point will be stay here, and this is known as a permanent eye center, because if mechanism is moving from this position to this point will be here always between 2 links. Okay, joint of these 2 links will be eye center always. That's why it is known as a permanent eye center. But this I13 and I24 are moving with respect to these links. Okay, so that's why it is known as a neither fixed nor permanent eye center. Okay, so as you can check here, I14 and 12 is a fixed eye center. 34 and 23 is a permanent eye center, because you can find that at a joint of 3 and 4. And last is a neither fixed and nor permanent. Now we are going to learn Arnold-Kennedy theorem, which is very important. Okay, there is not a longer derivation, is there, very simple theorem is this. So if you check here, if I am giving you one example, 3 links are there and connected in this way, making the triangle. Okay, this is the link number 1, link number 2, and link number 3. Okay, so you can locate the eye center here, where the connection, this is the I12, this is the I13, and this will be I23. Okay, 3 eye center you will find, because 3 links are there, and number of eye center is equal to number of link into n-1 by 2. So you will find 3 eye center, and you already locate that 3 eye center here. Okay, but when you check this here, if this A, B and C, okay, let's start Arnold-Kennedy theorem. We are going to learn this. It is very simple and small theory is there. So let's start with I am giving you one example. If there is a 3 links are there, and how many eye center you can find here, 3 links are there. Okay, check this. Let's give the name. This is the A, B and here C. So you will find the three eye centers. Where will be there that eye center? You can find here link number. This is the IAB. Here will be IAC and here will be IBC. So that's how you will find three eye center first. But you can check this point here. This point, velocity of this point with respect to this eye center will be in this direction perpendicular to link. But same point is on this link also. Same point is also on this link also. So according to, with respect to this point, motion of this point is in direction of this direction. So it is not possible is there. So that's how this Arnold-Gardner theorem is there. Statement is like this: if three body moving relative to each other, they have three instantaneous centers and lies on a straight line. Okay, don't confuse with this figure. This figure is saying that if three links are there and if there is a relative motion, eye center will be on a straight line. And in this case, three lines are there, three links are there, but they are not moving with respect to each other, they are fixed. And that's why they have eye center, and that's why there is only two eye center is there in a straight line, because there is no relative motion is there. Okay, if you check the like this mechanism, you can check here. There is, if you consider this link number 1, link number 2 and link number 3. Check this link number 1, 2 and 3. Eye center will be in a straight line. Check this. Check this line. You can check here. This is the I 1 3, 2 3 and 1 2. For these three links, three eye center will be on a straight line. You can check for any example. Like if you consider this link number 4, link number 4, link number 3, link number 2, the eye center is on a straight line like this. Check this in this line. Okay, you can check here. This is a 3 4, 2 3 and 2 4. So if there is a relative motion between the links and three links are there, all three eye center will be on a straight line. Okay.